In the series of ions shown above, calcium ion has the smallest diameter, while sulfide ion has the largest diameter. Explain why the radii vary in this order. So the hint is to think about what's in the nucleus of each ion, as in how many protons are in the nucleus of each ion. So as we determined in the first step, there are 20 protons in calcium, 17 protons in chlorine, and 16 protons in sulfur. So you can see there is this downward trend of amount of protons for our atoms here. However, they each have the same amount of electrons. They all have 18 electrons. So what we're looking at is the electrostatic force from the protons pulling on the electrons. And we're looking at how tightly held these electrons are in relationship to how many protons there are in the nucleus. And we can see there is a relationship. When there are more protons, there is a greater electrostatic force. Which pulls the electrons in closer. So when the electrons are pulled in closer, that decreases the overall radius of our ion. Meaning calcium is going to have the smallest diameter, and sulfur will have the largest one because calcium has the most protons pulling on those 18 electrons, and sulfur has the least amount of protons pulling those 18 electrons in. When there is the same amount of electrons but a differing amount of protons, the electrostatic force will vary, causing changes in the atomic radius.